Good evening and welcome to my shop. This is Bruce, and what we're going to talk about today is how I stitched up my crack. What we've got actually is a casting that's the main pivot point for a bandsaw for cutting cores on out on drill rigs when they take samples from the drill hole, and that was damaged in transit, and we had a very bad break in it. And I'll bring this forward, see if we can get it. Yeah, so this whole casting was broken through, right through, and so what I've done, what the customer's done, is ordered a new casting from Germany. Unfortunately, that's looks like it's going to take quite some time, and they need to get this back out on the rig. On a new rig to carry on work. So I've done all the other peripheral repairs, and what this is a plan. Plan B was to make a brand new one out of steel, and Plan C was to, or which I come up with today basically, is to do remedial works on this casting in order for it to be able to do the job until such time as the other casting comes. When that saw comes back to Perth, then we'll strip it down and we'll replace this with the spare. Now the biggest problem I had, what I decided to do is I welded it up just a bit to hold the whole thing together so I could reverse engineer it. But in order today to be able to actually machine this, because what I opted to do was to make a trough in here, machine out a trough, and put a plate in and screw that in. So what I did was I machined up a spigot because there was just no way of capturing this. I machined up a spigot from a hex bar, and I fitted that on. And then I jacked it up and set it up here like so. And then with my height gauge, we'll see if we can see that height gauge. No, you can't. So with the height gauge, I went around all sides and lined the whole thing up till it was, which was lined up, because when you pivot this, because it's at an angle, when you pivot it, you're also tilting it. So it took a bit until I got it the way I was happy with it. And then what I did was I proceeded to machine out a trench in here, and I used a corn cob cutter, and I progressively machined that down through and made that pocket in there, or trench. And then I took a piece of plate and I clamped that down on here using these clamps. I clamped it down in place, and then I started to drill and tap until I'd made up this complete setup here. And tomorrow I'll be buying the correct screws, the length of screws and so forth. Some of these holes went all the way through, and some of them there's other castings and webs in there. I also decided to come through here and capture a bit in there. So I've drilled down and I've tapped, and I'm going to capture this section here as well through screwing that. And in two places here I've connected to a web underneath. So in one of these is a very long screw, goes all the way down. Sorry, that one goes in here. This screw there goes all the way down and captures that crack through the web. So basically, once I've got all this screwed up, we've got a repair here which will sustain the work that's needed and possibly last forever. Who knows? And with a little bit of welding, I wasn't going to go to the work of welding this up fully, because that's a huge job. and very expensive. These electrodes are quite expensive. So tomorrow I'll clean this up, and wherever I've welded it, just make sure we've got a complete fusion here and so forth. So the tools we've used here, of course, is the vise. We've made this spigot. Our normal clamps. I've got some extender clamps here and a couple of trees, adjustable trees. We've used our the centre marking. We've used our carbide tipped centre. We've then drilled with this is 6mm. All the bolts we've made are 6mm. So we can see that. So I've drilled them down with 6mm for the tapping depth. With a 6mm tapping drill to the tapping depth. We've then cleared the top area of the plate with a 6mm clearance. Where we've got a through hole, we've used the gun tap, the machine gun tap, and where we've got a blind hole, we've used the spiral flute tap. Now, where we have to go in quite deep, these taps, the shoulder or the back here is much bigger than that, so I couldn't get down the depth. So what I did was I pulled out an old set, and I hate tungsten, but this was a set of tungsten taps, and the actual shank is smaller than the hole. So that allowed me to tap deeper in for these two areas where I'm connecting up, this third area where I'm connecting up. Other things we used, of course, was the countersink, a little handle for the tapping, a small one. The other ordinary tools. We also use the ruler to be able to line up, to get a line up on that web below. And these I have quite a few of these of different sizes. These are metric ones, and this one goes up to 300. But on the flip side, it's split over, and it goes from 0 in the centre here. It goes, in this case, 150 in both directions. And this is a very, very handy piece of equipment, because when you want to find something quickly in the centre or so forth, you want to find out what the radius is, you can very quickly just slide that along, and you can hear we're getting 42 on either side. So it becomes very easy on round things as well to mark up your centres. So that's a handy little tool to have. Allen key, chuck key, the key for the ER40, our digital vernier, a little brush. We had rags over the whole area here to capture all the dust, the dust and the filings and the cuttings from the casting, because we didn't want it in there, and all those rags have been thrown out. They were sacrificed. So this is a way of stitching up a crack. It's a little bit time consuming, but I prefer to do it this way than to do all the welding, as I said. So there we have it. I've stitched my crack up.